And hi, today this video from Viyet Science, and Viyet Science is one of the major units of Viyet Art, right? And today is the topic which I will discuss and show. It is amazing new topic and very interesting topic. The topic is talking about one very interesting molecules called vanadium. Okay, you can see the pictures here. The vanadium is amazing one element. Now why it is I'm talking about so important, and suddenly why this vanadium I am talking about. Throughout this video we will know much more about that what is exactly the reason behind that I am showing this video today, and what exactly the reason behind it. Everything we will know throughout this video. Now first, talking to vanadium, you must know that it is a natural atomic number is 23. And why is it so, that I'll tell later, but you must remember it is a natural atoms which is available on the various part on the earth. But what exactly the reason today the vanadium can be a very important atom rather than others atom during the crisis which we are facing. We are facing natural disasters, and we are facing disasters of huge flood and water level rise. So I think these problems and other many problems can be solved by this vanadium, and how it will help for those crises, managing those crises, that we will know here. Okay, so let's start and let's go for another the part to know about something more on this purpose. Vanadium is the atom, the atomic number is 23. Okay, and atomic mass is 50.9414 gram molecules. Now what is the electronegativity according to the pooling? 1.6, and density is 6.1 gram. The melting point is 1910 degrees C, and boiling point is 3407 degrees C. Okay, so the melting point and boiling point is much more higher than many other atoms. Okay, and very much higher than iron, right? But why today I'm talking, this material is act like a iron but much more sustainable than iron, because iron melting and temperature and boiling temperature is much less than the vanadium. So for those purpose we can use this vanadium very optimistically or very actively. Okay, and vanadium carry is in a special character that you will know here. Now if you come to the application of vanadium, you must know that 80% produced is used as a ferrovanadium or as a steel additive. I means the Fe2O2 oxide, right, which is basically with the water reaction with the iron, it's destroyed the metals, right? But to convert a metal into a steel we use vanadium. So vanadium is the protector of any kind of irons. Okay, and in prevent from any kind of reaction with the water with the metal. Okay, so this vanadium, this tactic and this thing can very helpful for upcoming future, because we know that when water is the problem today, we have a high temperature on earth, and that is the reason every single moment the sea level rise is the best incident on the earth. Because the sea level is rising, our lands are capturing by the waters. So in the future, when we try to build any kind of buildings, we have to use the metals for our any construction purpose. We have to use vanadium with those kind of metal things, so we can protect all these metals, and not just metals, every building's constructions from the water impactions. And that is the reason how it will use, that's maybe the scientist or the researcher need to understand on it. But the basic things which I'm telling you, that we have to focus on to produce much more vanadium. So from right now we need to go for a very essential search with the vanadiums now, and that's exactly things. Now let's know something much more. This is just a vanadium molecule structure. You can see how it's look like. Okay, and 23, right? So you can count as 23 molecules. Okay, and now just this structure, vanadiums, its ionic radius is 0.07 nanometer. This is a radius. Okay, and so you can see here, this is the radius and this atomic structures. Right, this is the normal vanadium structure. You can see the neutron, proton and electrons, and based on that we know how and what's the atomic number is a 23. So if you look on this structure, you will get this. Right, now just you can see here, right, 2, 8, 11 and 2. Okay, so first is 2, then 8, then 11 and 2. This is the structure, atomic structure. This is the vanadium oxide. Okay, and the vanadium oxide is basically the something which we need to understand that why it's happened. Exactly, the vanadium structure is look like this, and it's called the oxidation structures, and inside is structure like this. Right, let's look how with oxygen and vanadium is make a reaction. It is the called the, and now this is, if you go these things, it is talking about how vanadium reactions with oxygen and make this color. Okay, if you from right it started, from right is color violet, right, and it's exactly the color of lilac color. It is called the VH2O. Okay, so 6 number hydroxyl ion, it's called H2O, water ion, and with vanadium it's called the iliac. Then it's come through, you can see the green color, right, then blue color, and then yellow. Okay, so for green it is called H2O6 3 plus. Okay, the ion number is 3 plus. Okay, and so from right is a iliac, then blue, then green, and then our yellow color. And why it's happened? It is called ammonium vanadate V, NH4 V3, and all these oxygen ions colors are basically the vanadium forms the metal aquo complex. Okay, so when we replaced our vanadium onto on the metal, and how this metal is protected from this hydroxyl ion, because then it make those kind of oxygens and it protect metal from those reactions. Okay, so that's you need to understand. So yes, so let's this, and so this video made by Viyet Science to send a message that we can use this vanadium atom for our future purpose, protect our building construction from the reaction with the waters. Because of sea level rise and the very high temperature in the sea, we will face lot of water events like tsunami, more hurricane, more cyclone. Ultimately we are going to affect by the huge flood, right? And so we need to protect our building constructions. So that is why we have to add this atom into our cement as well. And as so for more something information and more how you can explore all these things, please contact Viyet Art, Viyet Science. Thank you very much.